Hey guys, welcome back to Day 2 Notes. We're going to start off with example 5, identifying whether this is linear, exponential, or quadratic. If you notice that our leading term is x squared, so I have a variable squared, that should let us know that our equation is a quadratic function. The domain of quadratic functions are negative infinity to infinity. And my range is going to depend on my vertex and which way my graph is open. My vertex is right here at -2, 1. And it's open up. And remember, range is y values, so I'm going to use my y value of 1. And since my graph is open up, it's going to infinity. And I'm going to put a bracket on 1 because my graph is actually touching that point at the y value of 1. So that's why it's a bracket. Since my graph is above the x-axis, I will not have any x-intercepts. But I will have a y-intercept at 0, 5. Since my vertex is at the bottom of my graph, it is going to be considered a minimum. And now for the fun part, increase and decrease. So you notice on the left side, all the way to my vertex, my graph is going down. So from negative infinity all the way to my x value of -2, I am decreasing. And from my vertex going to the right side, whoops, that's not what I wanted. My vertex going to the right side, it is going up. So from -2 to infinity, it is increasing. So I have my interval of increase from -2 to infinity, and my interval of decrease from -infinity to -2. And for example 6, this one looks a little bit different. If you remember that this is vertex form, which gives us our vertex at 3, 8. And it's vertex form of a quadratic function. So this example number 6 is going to be a quadratic. My domain is going to be from -infinity to infinity. And my range, again, depends on my vertex and the way that my graph is open. Since my graph is open down, that means that my range is going to be from -infinity, and it's going to stop at 8. But again, I put a bracket around that 8 because my graph actually touches the point. We only use parentheses when we don't touch that point on the graph. Since my graph is going open down and it crosses the x-axis, I will have an x-intercept. My first x-intercept is 1, 0, and my second one is 5, 0. Next, we're going to talk about the y-intercept. The y-intercept is going to be where my graph crosses the y-axis. If you'll notice, you can't see where my graph crosses the y-axis here. It stops right about there and it doesn't cross the y-axis on my given graph. However, we know that we will always have a y-intercept. So we can do a couple of things. the first thing that we can do is plug in 0 to my equation to find out what my y value is. Or we can use a calculator. I'm just going to work it really quick by plugging in 0. And we're going to follow PEMDAS. So I'm going to do my parentheses first. E for exponent. Then I'm going to multiply. And then I will add. So my y-intercept is going to be at 0, -10. You can check that in your calculator if you want. You would plug it into table and go to when your x value is 0. Now we're going to talk about max and min. Since my vertex is at the top of my graph, it is going to be a maximum. And now for increase and decrease. I sometimes determine increase and decrease this way as well. So I'll draw a straight line as best as I can through my x-axis, and that's going to be at 3. We know as I follow my x-axis to the right, I'm going to approach infinity, and as I follow it to the left, I'll approach -infinity. On the left side of my graph, from -infinity to 3, we see that my graph is going up. So that's an increase. From 3 to infinity, we'll follow my graph and see that it's going down, which is a decrease. So now I have my interval of increase from -infinity to 3, and my interval of decrease from 3 to infinity. Finally, we want to see if we see any similarities between the linear, exponential, and quadratic functions, or if we see any differences. So we notice that through all of this, our domain remained the same. Our domain is -infinity to infinity. Quadratic functions, they increase and decrease on the same graph. Quadratic functions also have a maximum and a minimum. Where linear and exponential do not have a max or min, and they only increase or only decrease. That is all for Day 2 notes of Unit 12. Have a great day.